Alrighty now, y'all listen up. Miss Ryder will teach y'all a thing or two about computer programming errors. You clicked on this here video, so I expect you to pay attention. You got that? Alright, programming errors. Let's get started here. Now, programming errors, they call them bugs. Why do they call them bugs? Well, this here moth got into a relay at the Harvard's Mark II computer system back in the 1940s, and when they're trying to figure out what was wrong, they discovered a bug, so they started calling them bugs. Now, you got three kinds of programming error types. You have logic errors, you have syntax errors, and you have runtime errors. They call them all bugs instead of errors. The logic error, that's an error that's a result of a mistake in the design of the program, such as a math error, getting steps out of order, failure to follow design specification. You also have, this is caused when the program simply doesn't write the program it should be written to achieve the expected result. Usually programs with these types of errors will run, but they either don't do what you expect them to do, or the results of the calculations are just plain wrong. Then you have these things called syntax errors. That's like having a spelling error. There are equivalent grammar errors in computer codes. Things like using commands that don't exist, leaving off parentheses, brackets, semicolons, not as instance, or you type in the name of the variables wrong. Errors of this kind occur when the programmer is careless, not focusing, basically not paying attention. Sometimes they'll cause the computer to crash. Sometimes they may not crash at all until they get right to where that bad code is. So the runtime errors. They occur during program execution. It's when you instruct the computer to do commands that cannot be completed, such as opening non-existent files, dividing variables by zero, referencing locations that are out of range. Errors of this kind occur when users enter illogical or unexpected values. You can't ever tell what a user's going to do. They might delete files, or their hardware might be working, and that'll fire up a runtime error. Usually programs with these type of errors won't run at all, or they'll crash eventually when they try and execute the defective instructions. Error trapping helps eliminate many of the sources of these errors. Now, bugs can be pretty hard to eliminate. A bug is any error in computer code that prevents the program from operating as designed or expected. I wish I could spray raid on a program, but spraying raid on a program would just cloudy up your screen and not fix nothing. So let's look at some scratch programs and see. First, you have logic errors. They're common to all programming languages because people are common to all programming languages. Get rid of people, maybe you get rid of the bugs. It's easy to get things out of order, forget to test a calculation, or just forget a step or two. In this case here, we're running a scratch program, and our sprite's going to say something, but computers go real fast, and it's going to say, join hello username, and I'm happy to meet you in a flash. The user will never see that. They'll get straight to the would you like to play a game thing. So in this case, probably should have had a delay in there in order to see any of this. Math errors and things like that are also logic errors. Then you get these things called syntax errors. Syntax errors are the easiest to find because a lot of times the computer will point you right to it. And block-based program users are restricted to just using the commands in the programming palettes, so it's kind of hard to get a syntax error when you don't get to type anything in. But in this example, we typed in number 1 equal 10, number 2 equal 15, number 3 equal number 1 plus number 2, except we spelled number 2, numer 2. And the computer's like, dude, that's wrong. And in Python here, it shows you exactly where the error is. It says the error, name numer 2 is not defined in line number 4. So it points you right to it. That's helpful. Runtime errors. They can pass by undetected if the error is buried deep in a complex program and the test failed to trigger the error. Programmers often can't predict the wacky things users will do, and block-based programming runtime errors don't occur that much, but they can produce unexpected results instead of outright crashing. Occasionally you can crash a block-based program, and this is an example right there. You go, oops, something went wrong. Usually that's called by just putting in infinite values or like cloning the heck out of something. With modern-day coding tools or interactive development environments, they can often point right to where your runtime errors occur. So the best way to find bugs, don't put them in your programs. Pay attention as you're typing to avoid syntax errors. Learn how to use commands that you want in your programs. Plan before you code. Pseudocode or walk through your plan before touching the keyboard. Use print a lot to check up on your program logic, see that the values are what you think they should be. Test your code every time you add a little to it. Add a few lines, test it. Add a few more lines, test it. It's a lot easier to find a bug in a few lines than you work for like 4 hours and have 100 lines, and then it's like, oops, something ain't working. And document, 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 as Gomer Pyle might say. Say what you're doing in your code so that you can figure out what's going on and explain what the steps are going on and why they're going on. Debugging tips. If you get a bug in your code, everybody gets a bug in their code, take a short break. Sometimes being fresh will help you see what you might have missed before. If you have several errors, fix them one at a time. Make sure they work before you move on to the next one. Read your code carefully, line by line, for syntax errors. Clear one section of your program at a time. Do a few lines, and now look at the next few lines. Step through your program and write down what the values and results are on a sheet of paper. Put in some print statements that will show you what the values are at certain points in your program. Step through your program by variable. Identify each instruction a variable name should be in, and make sure you're using the right variable. Then test your code with the values at the extremes, such as little bitty teeny tiny numbers, and use big giant huge numbers. The numbers at the extremes will tend to point out logic errors very clearly and also help you find runtime errors. So make sound code and debug your code thoroughly. So put these concepts into place with each program you code. Your programs will work much better when they are bug-free. Hey, thanks for listening to the video, guys. Have a great day. Bye!